C is one of the best known programming languages, probably. Became famous due to Unix. But B is sort of an obscure historic detail that people don't really know about. And that is because the compiler has probably been lost, at least it doesn't seem to be around anymore. So I wanted to play with this language because the first Hello World program was written in B, in Brian Kernighan's tutorial on the B language. And I was very frustrated that there was no way to execute B code. So yeah, I fixed that.
Was there an A?
There was no A. No, B was actually probably called B because it was a simplified version of BCPL, which was an earlier language. And somebody, maybe Dennis Ritchie, said that B was like BCPL filtered through Ken Thompson's brain. And also it had to run on a PDP-7 at the time, which was a very small machine and it was very constrained. But this is about the PDP-11 version that I wrote. But it's actually a fairly portable language. So it runs on a number of systems. And we're going to see a little bit of that. So let's just boot the PDP-11 first in this emulator here. This is version 4 Unix, which was found just last year, so 2025. And it's been read, and I got it to boot, and I made B run on it. So we boot from the arcade disk and type the kernel name Unix. And I will log in as myself. And here we are. Let's see, I have some files here. And hello B is a little Hello World program that I wrote. Unfortunately, not the same as Brian Kernighan's tutorial Hello World program, because that was written for a different machine that had a different word length. And unfortunately, it was dependent on that. So I wrote my own version. But to just highlight how B is different from C, I wrote this put string function here, so we can see the differences a little bit. This looks just like early C, main, put string, and a string. We have the asterisk for an escape character in B still, but that's just cosmetics. One interesting feature of B is that it only has a single data type, just the machine word. And that is the only machine-dependent part of the language, really. Everything else is really portable because it's compiled to an interpreted code or a threaded code, which people may be familiar from the Forth programming language. And the reason is that the compiler is very short because it had to fit into a small memory amount of memory, and it just couldn't be very intelligent. And just generating this this code for a stack machine was the reasonable thing to do, and that also makes it very portable. If we start here, auto, people know this from C++ nowadays because they repurposed the keyword, but originally it came from B and it just declares variables on the stack, automatic variables. There's no int, no char, no pointers, because we just have memory. We just have machine words to work with. We just declare two variables, I and C. I is our counter that goes through the string, and C is the character that we want to print out. You will notice that I have used the while loop because B didn't have for yet. So we have to use while. And because there is no character or byte data type in B, there is actually a function called char, which extracts one character out of a string. So it's just the base address of the string, and the index like just goes character by character. So we get that, compare against the end of the string marker, and until that is the case, we just print the character on screen. So to see that in action, let's call the B command and give it hello. This is just a shell script, actually. It calls two programs, and now we get an A out executable, and there we go, hello world. A little bit about the implementation, how this works, the threaded code. It's two programs, actually. The B compiler, which takes B source code and produces an intermediate code. That intermediate code is an invention by me because I don't know the format of the original intermediate code. There was intermediate code, but I don't know exactly what it was.
You need to be in Ken Thompson's brain for that.
Yeah, I did ask Ken about it, but the details he didn't remember. So this is what the intermediate code looks like. And if we now run the assembler, the B assembler on it, hello.I, hello.s, that now produces something that can be assembled by the Unix assembler. So this is what the program comes out to be. And you will notice that this is not machine code. This one is, but most of it is just the threaded code that the compiler generates, and it's doing just a very straightforward thing. And yeah, there you can see the way that B used to work on the PDP-11. The compiler does generate the original code from the binaries that have survived. So there are a few B binaries. We have a standard library in B and the threaded code implementation, but no compiler, no large amounts of source code. So the biggest that we probably have is, I hope I have this here, yep, is probably the B compiler itself. So you can see this is what B looks like. It's based on the earliest C compiler that has survived, and it's kind of morphed backwards in time again to generate B code and so on. I'm gonna
So what do you do there? You take that early C compiler and you go, right, okay, let me go through that and edit it so it works with B? Or?
It's not, I didn't really edit it. It was more for inspiration. Like I took the structure, variable names, like where it made sense to retain it. The compiler is constructed a bit differently from the C compiler, but you can still see that it used to be a B compiler. So you can see that the B compiler isn't even 1,000 lines of code of B, and the B assembler is even shorter. So yeah, you can write a compiler in like about 1,000 lines of B code that compiles itself.
Yeah, and did you do that from looking at B programs that you had the code for?
Yeah, so the things that were left over that had survived were yeah, like object code that you would link into B programs, like for instance printf and printn. They are in the standard library. And that had survived, and there was source code for those functions in the documentation, so you kind of can match what the original source code should generate. And yeah, that way I was able to reason my way through how the compiler must have worked. And yeah, again, it produces the original code for all the code I've tried on it. And one of the early bigger B programs was Yak, the compiler, yet another compiler from Steve Johnson. That early B version has not survived. There is some early C code, but yeah. So yeah, that's kind of what I can say about B.
And are some of this stuff on GitHub? Could people go and have a look at it and play with it?
Yes, I actually have a guide for how to install it on these old Unix machines. It's a bit chaotic right now still. I have a bunch of ports to RISC-V, even to MIPS, and x86, PDP-11, PDP-10 even on ITS. So it is portable, and it's a very fun, tiny language. You can write a compiler probably in something like awk or any simple language. Like it's a fun project you can do. And yeah, it's a very sweet, short language.
We're a loosely organized group of computer hobbyists. We kind of met each other at vintage computer festivals. And all of us were sucked into the rabbit hole of pre-microprocessor computing. And we consider them not to be replicas, but more like computer.